Please share. Yeah. Okay. So today, as we discussed, we will continue with the other parts of the Kafka, other sections of Kafka, what we stopped earlier. Last time we did something about the replication and all those things in the in-sync replica and many other stuff there. Okay. So yeah. So it was a replication, and then how the in-sync replica list is there and how it comes out, goes off. Then we also discuss about the high watermark offset and the consumer groups, how they interact with the topics. Okay, so that is what we discuss. So today we'll focus more on the Kafka workflow. Okay, so one is Kafka workflow and the other will be Zookeeper. Okay, how Zookeeper is gets involved in the Kafka and what is its role. Yeah, and as I say always, I just get all these information from this book, whatever I'm referring to, as well as I go around in different blogs. So I will always share the blogs, whatever I have, referring to. So in this case, I'm referring from this blog, and so we can always follow for more details to the blog if required. And also, anyone wants to chime in for or add anything, always you can interrupt me, stop me at any time, and then you can actually add anything to the discussion. So it's an open discussion. So now, what is the first thing about the Kafka workflow? So because we know what is Kafka? Kafka is simply a collection of topics, and it is split into partitions. I'll just go to this diagram before going in there. So this diagram actually is something like I just copied it from some other site, and it is it is basically class diagram, I think so, of all the components on a high level in the Kafka. At least the more important ones. Okay, there might be more in this because Kafka is a very big system that way. So if you see, we have these producers here, and I think you are able to see my mouse movements, right? The cursor, mouse cursor. So this is the producer, yeah. So your producer, which will actually publish messages to topic, and then we will have consumers who will be subscribing to topic, and then consumers will be a part of a consumer group, and consumers will now topics are actually have zero or more number of partitions. So that is what it shows here. So one topic can have multiple partitions, and there will be multiple such topics, right? So and every partition will be replicated. So that is what it shows here. Partition will be replicated for one. It will be yes for if it is only replication factor is one, it will be just a single leader replica. But if it is more than one, it will have also in sync replicas, and that will be like the followers. Okay, so that is what the replica leader replica and in sync replica shows. So usually you at least have to have a leader replica, and but replication is always there, so you'll always have more than one replica. One will be leader and the others will be followed. And in the followers also, you will have some of them as an in sync replicas, and some will be just followed, but they have just shown you the in sync replicas. And now this is what the high level about the cluster. So you will have one or as one or in a cluster you'll have one or more brokers. So brokers will have all these partitions, which will actually on high level constitute to some topics, and there will be multiple topics and all those stuff. But producers and consumers are external to the cluster, and they interact with the cluster. And also Zookeeper is an external to this cluster. So cluster interacts with the Zookeeper for all the information, and then the Zookeeper has its own replicas like the leader and follower. And I think we discussed that in one of the sessions. So this is the high level class diagram of the Kafka. So now we know Kafka is a simple collection of topics which is split into one or more partitions, right? This way. And a Kafka partition is nothing but it's an ordered sequence of messages, right? And each and every message is identified by a offset that we discussed last time. And all the data in the Kafka cluster is a union of partitions, basically, right? So incoming messages are always written to the end of a partition, and the messages are sequentially read by a consumer. Okay. And for durability purposes, every time when a producer sends a message to a partition, it is immediately stored in a persistent storage. And also Kafka provides, in fact, till now we were discussing only about the publish and subscribe model, but Kafka, they say, provide both publish subscribe model and also a queue based messaging system. Okay, and we'll come to that when we are discussing the flows. And it is like they say, it's a fast, reliable. Of course it's fast because it just has to quickly store into the persistent storage as it's an append only log, like write head log, and it doesn't do anything further than that, and rest of the things are taken care by the cluster. Okay, so then it is also reliable because you see replicas there, everything is replicated, and then it is persisted, and it's fault tolerance for the same reasons, because it is replicated, and you have almost a zero downtime. That is what they claim. And in both cases, for like the publish subscribe or maybe the queue based way, producer simply sends message to the topic, and the consumer can choose any type of messaging depending on their need. Okay, so let us understand how the workflows are. Okay, so to start with, this will be the first workflow, and I think we have gone through in different we were discussing the different components of the Kafka, but here it will be the same type of again reiterating the whole previous discussions, but it will be in more of a single flow, and we'll really understand how exactly the flow is happening over here. And therefore they have specifically added this workflow section, and it might be a good thing to discuss also if we are asked such a system design question in an interview. So the workflow of a pub sub messaging, right? So now it actually starts with a producer. That is what always says. It's like a producer will send a message to a topic at regular intervals. So this is also important. So what it means here, that is what I got from reading different blogs here. It seems like, Kafka always sends messages in a batches. Okay, so it actually waits for some time for all the messages to accumulate. So that is why it is a regular interval. And then it actually, when it gets a certain number of messages, and then it will send those messages. Okay, so there are two ways. One is it waits for a certain number of messages, or it waits for a certain time, and we will see that later also. But for now we can just assume that it's going to send a bunch of messages or a batch of messages. And also these batch of messages, actually when they are sent, they are compressed at the producer itself, and then they are sent. So whenever they are sent to the topic or maybe the partition, we'll look in the flow, but they are also stored in the compressed form. And even the consumer, when it actually subscribes and pulls all those messages, okay, so that time also the same compressed form is given to the consumer, but when consumer actually tries processing those messages, it uncompresses. So the compression part is not uncompressed in the Kafka broker, it is done only at the consumer end. So the Kafka broker stores all the messages in a compressed form. So that is what it means by it is sending messages to topic at a regular intervals. Okay. Now here the Kafka broker, it stores all the messages, as we said, in the partition configured for a particular topic. Okay. So there, and also it ensures that the messages are equally shared between the partitions. We'll go back to this diagram over here. And if you look at here, there are 3 points, one below the producer. And it says that whenever producer is publishing any of this topic or sending any messages to a topic, it sends in actually the three ways. One is round robin, or maybe the key based ordering. So that is what we were discussing more. This is the second one, the key based ordering. And the ACT strategy, actually we will discuss later because it involves some other things. So that won't be discussed today. I think it's something to do with the delivery semantics. Okay. So so what round robin means? Okay, so first let's go to what key-based ordering means. So we already know that producer actually topics are made of different partitions, and producer can directly write to a partition. That is what we were always discussing previously. And what means is, whenever we get a particular message and we look at the key and we understand what the key is, and based on the key we can decide which partition we have to store. And so all this information, which key represents or which is mapped to a partition, all this information is stored in a Zookeeper. So I think there might be different ways of partition. As we said, like, partitions are like a subtopic. You can actually assume that, so a certain or same type of keys will always go to a particular partition. So that is what we always discussed, and that is why we can also maintain a sort of ordering in that particular partition. And so that strategy is called as key-based ordering. But now here they also discuss round robin. So what does that mean is, all the partitions are same in a topic. They are not different. Okay, so whenever message comes, okay, so then it is actually distributed among the partitions. So you actually uniformly distribute among the partitions, and then the load is uniformly distributed. But in this case, all of the messages are all of the same type, maybe, or they don't care about the categorization based on the subtopic. Okay, so that is why the round robin comes into. And so there are at least two ways till now we can send, and that is what they talk about here. It ensures the message are equally shared between partitions. If and when it shares, if it says it shares in the round robin, so it shares between partitions. And therefore, if producer sends two messages and there are two partitions, Kafka will store one message in the first partition and the second in the second partition. So that is what the round robin way it is. So then we all know how consumer subscribes to a specific topic. That is what always done. And then once the consumer subscribe to a topic, Kafka will provide a current offset of the topic to the consumer, and also save the offset in the Zookeeper and symbol. Okay, so that is the way it remembers the Zookeeper offset. The offset is remembered in the Zookeeper and symbol. But we had discussions, and also I think Nick came up with saying that Zookeeper not actually doesn't store all the offsets nowadays, and actually offset is some sort of a topic, and it is stored in a Kafka itself and not in a Zookeeper. So we can come to that later again. And also that is true, but these are the earlier versions of Kafka, and that is the way the offsets were stored in those times. And the consumer will request here also, you see, the consumer will request in a regular interval for new messages. So here the consumer is also doing a batch processing. So it doesn't go for each and every message, but it actually requests the Kafka in a regular interval, and it's like a polling. And for example, if it's 100 milliseconds, it will keep on polling for 100 milliseconds. After every 100 milliseconds, it will go and actually request for whatever the messages are from the current offset, whatever he is actually using. And once the Kafka receives messages for the producers, okay, so that is what the generic one, like when a broker receives a message from producer, then only it can forward the message to the consumer. That is obvious, right? And consumer will receive the message and process it. And once the message are processed, the consumer will send an acknowledgement to the Kafka broker. And once you get the acknowledgement broker receives it, then only it changes the offset. And so the offset is actually moved to the new value, and that is again updated in the Zookeeper. So that is what the whole cycle repeats, right? So, and since the offsets are meant in the Zookeeper, the consumer can read the next message correctly, even if there are server outages, because Zookeeper and the Kafka cluster, they are two different systems. So even if there is an outages, so both of them come back again. So Zookeeper will always remember what position of the offset in a partition the consumers were earlier. So it can always start from that position. And then it says the above flow will repeat until the consumer stops the request. And also consumer has an option to rewind, skip the desired offset of any topic, and read all the subsequent message. So the offsets are actually it's not like a queue based, because all the data is persistently stored as a write ahead log. So you can always rewind and skip and do anything with the offsets, and that is the beauty of it, because it's not like once you read a message and it goes out of the queue. That's not the way it is here, right? So because this personal storage is more durable, and also we know the retention, it depends on how long the messages are going to be based on the retention policy and all that stuff. But if the retention policy is you never expires, it means that the messages will be in the hard disk forever, and therefore you can use that for different ways, because sometimes the analytics would like to uh, view the previous data, and is always good in those cases, right? So that is what was the workflow of a pub sub messaging. And I think we discussed most of it last time also. But in case if anyone has anything to add or any questions, please let me know before we go to the second workflow.
So in that key value, I think, right, let's say if many values comes corresponding to a given key, right, that will go to a single partition, right?
You mean to say
there were three
order,
strategies, right? Yeah, one was like round robin, another was like key value. So let's say for given key, this particular partition is responsible, right? So if many keys, data comes with the same key, then that partition would be, what do you say? I mean, a lot of traffic will be directed towards that particular partition. That could be one of the disadvantages, right? In key-based sharing, or
actually, so they say, all of these messages are sent in batch. Okay, so when a batch of messages are sent, then then you are saying when we get a bunch of messages which are of different keys. If it is for same key is easy, right? Because see, if you have a batch of messages which are sent to a partition, as it's being sent in a batches, so the network latency, what you say, the bandwidth, everything is not consumed because it is compressed also. So therefore, you get a good what you say, high throughput also, because you are sending in batches, right?
Yeah, but for that given key, lot many requests will be there on one partition, right? That would increase more traffic. I mean, like not traffic, I would say like more load on that given partition. Let's say 1,000 values comes corresponding to given key. So it would be directed to single partition only always, right? The rest of the partition will be vacant and this will be overloaded. Like in round robin, what happens? It goes to every partition one by one, right? So all of them are holding the balance. None of them is highly overloaded, right?
Yeah, you can say that, but if you look at the partitions, the way they are designed, they are very huge partitions. And if you see that, like they talk about hundreds and thousands of messages being stored. Yeah, so that it is capable of doing it. But what you also say makes that point is also valid. But looking at it, because the way they are described, because really if you go in more internals and if we actually try playing around with this, we'll really come to understand, we'll know what things are, and there surely will be some limitation, right? Because the hardware resources are there, underlying lot things are there, but they have tried to overcome all the limitations, and at least for the applications what they are serving. So based on that requirements, they are able to manage it. That is what they are actually claiming. But what you say makes sense, because
Kafka has massive storage also, right?
Yeah,
huge amount of data.
Yeah. So the only reason what I think is, because even if we receive more number of keys and if it's distributed across partitions, because we just have to append and also store in that write ahead log. So also the disk, the blocks of the disk are stored in a sequential manner. So you don't have to even do a lot of disk seeks, So that is the way the whole thing, the partitions are designed. So I think we might come across when we are discussing some of that storage part. But not today. But that might be one way actually to address this issue. Yeah. But you say, as you say, that is also one thing to maybe we can explore more about it. Yeah. But that's also valid point. Yeah, I agree.
Can we discuss on key-based partition? It's interesting to understand how do we specify.
Your voice is echoing, I think.
See,
Right,
key-based
sorry.
partition, what we discussed last time, and it was something to do with more like that the way I understood, maybe you can add to that, Nick. So if we have a topic like this, and then we have these three different partitions. So the way I look at it is, because a topic will be something like, if I say it's something to do with the cars. So my topic will be cars, and then the partition will be for the model-based partitions. So one will be like the different models of a car. So that is the way I look at it. It's a partition is like a subtopic.
In relation database, when we create a table, we can specify, okay, we use list-based partition or haste-based partition for this particular table, yeah. I do not know how do we do this the same for Kafka. Yeah, usually we have, let's say we have 4 number of partitions, yeah, and it looks like a client is responsible to send to a value to appropriate partitions, yeah. I mean we can have, we just need to specify number of partitions, and client is responsible for routing, no?
Client, what
Nick,
was the last statement?
your voice is like echoing too much,
Yeah, but yeah, I could understand. Last statement, what you said, the client is responsible for?
For routing, yeah, client is responsible for routing, not a broker. Broker will not route our pair to appropriate partition. Yeah, I just trying to understand who is responsible for routing. As I can see, I was searching in internet and look like client need to specify a partition, a partitioner, a class which will return particular partition number based on key.
Yeah.
Should,
Yeah, that is
yes.
what. So that partitioner actually, whenever we get a key, so that partitioner will actually decide which partition the message is going to go based on your whenever it receives. Yeah, but that information is already stored in the Zookeeper.
Oh, but why? If we store it in Zookeeper, yeah, it means that our Kafka cluster is aware about such partition schema, yeah?
Yeah, that is what it is. It is actually at least what I read. So our Kafka broker has to be aware of all those things. Then it is not possible, isn't it? Because see, everything what we see as I'm understanding Kafka, they are trying to put everything in the Kafka. So the producer and consumers are almost not smart that way, right? They just have to push everything, and the Kafka broker and the cluster, along with the Zookeeper or maybe non-Zookeeper also in the new versions. So they have to have all that information and take the decision how they are going to route all of these messages to different partitions. That is what I think.
Yeah.
Maybe
Yeah, but
can add that.
please go ahead. Yeah.
By the way, can you explain what you are discussing? Like, what he asked? I didn't understand.
Oh, he's saying, yeah, Nick, correct me if I'm wrong, because your voice is too much echoing, so people are not able to understand. But so what he's saying, so whenever a producer sends a message to a partition, okay, so how does, because producer is a client to the cluster broker, isn't it? So how does the producer know what message has to go to which partition? Okay, so that should be, he's saying there should be some other service, something like a partitioner service, which the producer should use, and then based on that service, the producer will understand this message has to be redirected to the partition 1 only or partition 2. So then I said it is correct, but instead of having a service, it will be, this information will be stored in a Zookeeper. That schema will be stored in a Zookeeper. So whenever he gets a key, so that producer actually goes and gets the data, metadata from the Zookeeper and understands how this mapping is done. And then only that particular message will be diverted to that partition.
Yeah. Okay. I think I understood it. I mean, if you want to send a message to particular partition, is that
Right.
what you're getting at?
Yeah, that is what he was talking about. Right.
Okay. I think you can. I mean, in the Java client, you can actually specify the partition number. I mean, it will route to that. But it also depends on the partitioner itself. Like the interface, it uses default partition, and whatever the key you give, it takes the hash of it, and it evenly spreads across, like
Right,
based on
right.
the
I
hash.
was also thinking about the hash based, but they're not talking about the hash based anywhere.
Uh,
Yeah, so
yeah,
I just
but
refrain
yeah,
from mentioning
internally,
it. Mhm.
or you could even implement your own. There is like interface, like partitioner interface. You could do it.
Really? Mhm.
Yeah. So you could actually like route it to particular partition based on the key.
Oh, okay.
That's something you will implement like
Oh, okay.
on the
Customization.
application side.
On the producer side, okay.
Yeah.
Because the producer API usually has that, I was
Yeah,
referring.
it already has that. It has like default partitioner, right? Which
Uh-huh.
will take the hash and it will route it. But if you want a custom routing logic,
Oh,
that I
really?
think you would, yeah.
Okay. Okay. I think then that answers Nick's question, isn't it, Nick?
Yes, thank you very much. Yeah.
Okay, thank you. Yeah. So that was the thing about so this one. So now the second is what is about the workflow of queue messaging or a consumer group. Now here actually, so what this is why they call it as queue in this messaging is slightly different, but it's almost the same again. But they are actually referring to queue messaging. It is like a queue messaging. So what is said, but you'll understand only if you complete the whole flow, then only it's really uh, evident what they mention by queue messaging. But most of the time, it's still a publish subscribe model only. So what they say is in a queue messaging system, instead of a single consumer, okay, because a group of consumers, because that is what the consumer groups are, right? Which have the same group ID, subscribe to a topic, and in simple terms, the consumers subscribing to a topic with the same group ID are considered as a single group, and the message are shared among them. So whenever they talk about a consumer group, it is not a separate entity as such, but all of those particular consumers who have a same group ID, they actually form an entity like a consumer group. Okay, so there is no such entity, but it's like a they just form a single consumer group based on if they have share the same group ID. That is what it says. And now if you look at the flow over here, and we all know that in Kafka, the consumer works on a pull-based approach. Okay, so that is what talks about here. First, the producer sends a message to a topic in a regular interval. That is what we discussed earlier. And also, Kafka stores all the messages in the partition configured for the particular topic, similar to the previous what we discussed. And now here this starts. If a single consumer, initially there will be a single consumer. If we just imagine, it subscribed to a specific topic and say the topic is something like topic 01 and the group ID is some group 1. Okay, so we have topic 01 and group 1, and Kafka interacts with the consumer in the same way as a pops up messaging until the new customer subscribe to the same topic. So when a new consumer again subscribe to same topic 01 with the same group ID, so then what it says is the Kafka switches its operation to a shared mode, because earlier if we had multiple partitions, okay, maybe two partitions in a topic 01, so a single consumer would actually be interacting with both the partitions and consuming messages from both the partitions. But as soon as two consumers are there and we have two partitions, both of these consumers will be interacting with separate partitions. Okay, so then it appears to be like a messaging queue, isn't it? So messaging queue, usually what happens if we are using the queue based messaging, in that you are not sharing multiple consumers are not sharing to a particular partition in the same consumer group. Okay, so that is why they are referring this particular workflow to be a queue messaging way. Okay, and also if you see, once the consumer exceeds the number of partitions, the new consumers will not receive and all that stuff. It will remain idle. Okay, and it will be just remain idle till someone doesn't unsubscribe and all that stuff. Okay, so this is what a consumer, a queue messaging is, and it's all again the pub sub only, but it appears to be like a queue messaging, and therefore the workflow for a consumer group is a queue messaging way. That is what they talk about it, and therefore this feature is also called as a consumer group. In the same way, Kafka will provide the best of both the systems in a very simple and efficient manner. And still we are actually not storing all of these messages. They are not going to be deleted, everything, but it appears to be, and therefore they say it's a queue messaging system for the only for the consumer side. Okay, and any questions on that, or if someone wants to add anything in it? Okay, so hope I think this is clear, and I see something in the chat is okay. Okay, Nick is trying to join. Okay, no problem. So now, so the next topic is about the role of a zookeeper. And
so how does a producer know that how many partitions will be there? I mean, producer will talk to Zookeeper then, right?
for how many partitions for a particular topic? So all that information will be in the Zookeeper.
So producer has to talk with the Zookeeper to get all those info, right?
See, there are two ways. Now, if you really go to the Zookeeper, you will understand it. And now, because it's being evolving, this whole Kafka thing. Earlier, what used to happen, I think, the producer used to initially, whenever it still interacts with the API using an API, but it goes and talks to the Zookeeper to find which partition it has to talk with. And then they moved out that also, like how they moved from the consumer offset to an offset topic. Then they moved out the producer actually interacting with the Zookeeper to get the information of the partition based on that partition service. And then they are actually, the producer directly interacts with any of the partitions broker, and the broker will actually get the metadata from the Zookeeper and then inform the producer which partition it has to talk with, and now that is also going away. So you don't have a Zookeeper at all. Not the new version, what they are actually thinking about, I'm not sure whether it is already implemented. And so it is evolving. So that is, I think it's like in 3 stages. So the very oldest way was like, okay, maybe anyone can correct that. So it was like this, you have a Zookeeper, and you have all these brokers, 1, 2, 3, and you have all these producers and the consumers. And if you look here, all these arrows, this is shown as a dotted here, okay, and that it is for a reason also. So all the producers also interact with the Zookeeper, the brokers also interact with the Zookeeper, and the consumers also interact with Zookeeper. So that is what was the very initial implementation or the design architect of the Zookeeper, of this Kafka. Okay, and so therefore the role of Zookeeper is very important. And eventually, first they actually went away with this consumers, because the consumers, all the information of particular offset was stored inside a broker, inside one of the broker in an offset, in a topic, sorry. And then they actually moved this, so the dotted line from producers to Zookeeper also. And now the producer is directly interacting with the broker, and then the broker will interact with the Zookeeper and get all the information. And now the last version will be like without a Zookeeper altogether. All of the information will be in the Kafka brokers in different offsets. Yeah. Right. Yeah. So that is what I at least know. So now, okay, if anyone wants to add, he can surely add here. Okay, so now Zookeeper is, what is a Zookeeper? It is again a centralized service which maintains the configuration of a data, and it is very flexible for and very robust for synchronization for distributed systems and all that stuff, right? That is what the definition of Zookeeper is. Basically, for me, it's like it's a configuration system and also a leader election, isn't it? So that is what also is an important part of Zookeeper. So what this Zookeeper does is it actually manages the whole Kafka brokers in that cluster, and also it maintains, because how does it manage that? Actually, it maintains the list of the brokers, and all that information is maintained in Zookeeper. So whenever a producer actually is interacting with any whole of this topic, whole of the Kafka cluster, it will come to know from the Zookeeper which of the brokers are actually alive and which of them are not alive, based on, because all the brokers keep on sending heartbeats to the Zookeeper, and that is the way it gets the information which broker is alive. And there might be many complexities involved in it, right? It's not a simple one, the way we were discussing about Zookeeper, how you consider whether broker is alive, or maybe it is out, or it's failed as dead, and all that stuff. So there are complex algorithms for that also. But for very high level, all this information is actually passed on to the Zookeeper from this broker. And so also the producers can interact. So that is one way of understanding what it does. Second is the Zookeeper is responsible for choosing the leaders of the partitions. Okay, in case, because whenever a producer interacts with a broker or a partition, the partition is replicated. We all know that the leader partition is only responsible for reading and writing of messages, isn't it? So that is why if that leader fails in, so the Zookeeper is responsible for electing a new leader, and the way it does is based on the in-sync replicas, whichever those in-sync replicas are for that particular partition. So the closest in-sync replica is chosen as the next leader. Okay, so that responsibility is also with the Zookeeper. And secondly, it also maintains the information of the offsets. Because the new versions don't have that, but the consumer offsets was also maintained in the Zookeeper. And so eventually, whenever the consumer wants to go for the next offset, you refer to the Zookeeper and get that information and move on, right? But you look at the older version was this way, and then so what are the other stuff what actually Zookeeper as a central coordinator does, and that is what actually is referred here. So what it says is the role of a Zookeeper in Kafka is store the states. So these are the four things what it does for a broker, and these are the two things what it does for the consumer. One, it stores the state, and so whether that is what I discussed, right? So whether a broker is alive or not, and all those things, and the heartbeats, based on the heartbeats, all those information, the actual state of the current broker is stored in that in the Zookeeper. That is one thing. And then also about the quotas. So if in what it said is, in order to have a different producing and consuming quotas, so how many producers and how many consumers you really want, because you should not overload the system, so those quotas also are well defined, and then based on that, maybe some decisions are taken inside the Kafka cluster. So therefore the quotas are also important. So the Kafka broker allows only some client based on the quotas to get into it. So that is one thing. And the second is the replicas. So all the replicas, like the in-sync replicas, the followers, and the reader replica, all the information per topic wise, per partition wise, that is stored in the Zookeeper for this broker, for each and every broker. And then nodes and topics registry. Basically, Zookeeper will store nodes in the sense like it's again the same brokers, and that topic registration and all that stuff. So that is what it means by the nodes and topic registry. And for consumers, the offset, as we all know what the offsets are, right? Based on the consumer when it is dealing with a particular partition, what offset it is reading, the current offset that is actually stored in that in the Zookeeper, and it also has a registry. So every consumer in Kafka also has their own registry, like as in the case for Kafka brokers. So and also all of these are stored in the Z node, so it can be destroyed whenever a consumer goes down, and so the registration process is again made automatic by the consumer whenever a new consumer joins in. So this is what they talk about what are the major things, what are the Zookeeper stores about the Kafka. Okay, so any more things anyone wants to add in this?
So quotas is like how much it will, I mean, like how much the consumer can consume from the given partition, right? I mean, those things will come under quota, isn't it?
I frankly am not very clear, but the way it was said is the number of producers which you can actually allow to connect to a Kafka. Maybe then the number of producers or consumers also, you cannot have more than certain number of consumers, and based on the partitions or based on the topics maybe. So those quotas are already defined, or maybe the system, and it might be configurable also. So that is one thing, that is what I look at, because you can keep on increasing the number of producers. It might be more overloading to the system, because they still want the system to be always on, highly available with the low latency and the high throughput, isn't it? So that is what their whole objective is. So in case, because it's too huge, it can go, you can have huge spikes also. So then somewhere you have to control that, and that might be the quotas. That is what I think.
Because a number of consumers, you will be equal to number of partitions for sure, right? That's the worst case. You can't.
Yeah, that is the max you can do, but if you have more number of consumers, they are just going to remain idle. They are not doing anything, right? So also on the consumer part, what was said is the one what I read is it is pull based model for a reason also, right? Because so imagine if it was not a pull based and it was push based, and if the producer was pushing a lot of messages to these brokers, so we have a huge backlog, and then if you push the whole backlog to the consumer, and it is not able to process that many number of messages, because the consumer knows its capacity, isn't it? So the broker doesn't know consumer's capacity, because they are totally different entities. So if we just push all of them, that will be too much overwhelming for the consumer to process it, and then it might overload the consumer. So it is always better to consumer to pull the messages from the brokers or from the Kafka cluster. So that is the only best way to do, and that is the way it is designed, and it's more efficient and well proven.
Yeah. And even, I mean, it makes sense also, right? Because consumer will have their own offset in the Zookeeper. In case if it fails, it knows from where it has to pull, right?
Right.
Rather than these responsibilities taken by producer.
Correct. Yeah. Okay. And one more thing, what they talked about here is how do producer or consumer find out who the leader of the partition is? And it is said in the older versions of Kafka, all clients, the producers and consumers, basically these are the two clients what we were discussing here. They directly talk to the Zookeeper to find the partition leader, and Kafka has moved away from this coupling in the latest releases, and now actually the client fetches it from the metadata information. So I think it is slightly moved this way. So now what happens is the Zookeeper cluster, actually if you look at it at the previous version what we discussed here, you had these arrows, actually the consumers and producers also referring to Zookeeper, but now they have moved out, and it is like this. You see the broker only actually interacts with the cluster. Okay, so if anytime if a producer wants to find out where the message is going to go to which partition, it connects to one of the broker, and it asks for the leader of that particular partition where this message has to go, and the broker responds with the identification from, but actually before that, it actually, this metadata which is stored in the Zookeeper cluster, based on that actually it responds. So it talks with the Zookeeper cluster, or all the brokers also have a certain amount of cached version of the all that's metadata, and therefore it can quickly pick up from that metadata itself what is cached in the particular broker, and it can inform the producer which leader it has to talk to, and it is in which broker and which partition. So that metadata which is actually centralized in the Zookeeper, it is also stored based on whatever the cache values were, based on what messages it had, the previous messages were from the producer. So those that particular information of the metadata is already stored in each and every broker, and that is an easy way of doing it. So this is one way actually it is done. So the critical information is stored in the Zookeeper, and also the Zookeeper is replicated. Okay, so yeah, it has its own cluster and everything. So both of these systems, even the Kafka system with the cluster system as well as the Zookeeper, they are two big systems, isn't it? And they both are replicated, and they I think whenever we at least just the previous versions, whenever they had to install or deploy Kafka, they had to install and deploy Zookeeper also for it, and both had their different configurations and all that stuff. Correct. So that was slightly cumbersome because you have to maintain two different entities altogether, and it has an overhead. And that is the reason Kafka is actually trying to be more of a Zookeeper-less system. And
Yeah,
they
they're
are
actually implementing it.
Yeah, the raft consensus algorithm in the brokers itself, isn't it? Yeah. So they are saying now this metadata, instead of lying in this Zookeeper cluster, will be on all the brokers. It will be replicated on all the brokers, and that will be, and also you will still have a leader or something like that, and then they will follow a raft consensus algorithm. Right. So that is the way they will have. Then they will have a quorum also, and that is the way they are trying to minimize the lesser impact, or maybe whatever the overheads they have. So what they talk about is Zookeeper is somewhat like a file system trigger API on the top of a consistent log, and Kafka is a pub sub API on top of a consistent log. So almost both are the similar systems, isn't it? But only Zookeeper deals more with the file system trigger API, and this trigger deals with more of a pub sub API, but they still follow the consistent log system. So whatever Kafka is doing to some extent is almost the same way what Zookeeper is doing in a different way. So why to have two different systems whose implementation architecture is slightly similar? So they can be easily combined in a single architecture, and that is the reason they thought of moving out from it. And also, if you have two different use systems, you have overheads, because you have to configure them independently, you have to maintain them independently, and then still they have their own problems because you are interacting with two different systems. So if we have all of that in a single system, it is always better because everything will be managed by a single system. Yeah, but it will also have its own challenges, but they won't be that huge, because like if we have a producer, now it has to go talk to a broker gets the information from the Zookeeper for a metadata, it stores across all of these clusters. But that is an additional thing, right? Because if we have the metadata and if we store it in a broker itself, one of the broker, and then it becomes a leader, and that will be shared, that will be much faster than actually going through Zookeeper and getting it. And also again, all those brokers, they sending the heartbeats to Zookeeper to external system, so that will always be another challenge. So if you have all this information stored, it is going to surely help a lot, but that would be more challenging again, because if a leader fails, how things are going to be handled and all that stuff. But that should not be a huge issue than what it is currently now. That is what I understood after reading through all of this information. So they're going to follow the quorum controller, and with they call it craft, right?
Quorum controller within the Zookeeper cluster, right? Like if
Yeah.
these minimum of 3, I mean, whatever quorum they have said.
Yeah. They call it Kafka raft metadata mode, and it's like the KIP 500, whatever it is called as the Kafka
cluster
improvement
index.
performance.
Yeah. Kafka
Yeah.
improvement performance.
Yeah.
Even we have zombie Zookeeper, like if the leader fails, I think that comes into picture.
Yeah. So this was it. Okay, and then now if we slightly go, so this is one interesting thing what I found, and it is about the performance, achieving performance by performance tuning in Kafka. Okay, so Kafka is what is the real performance tuning to be done in a Kafka? Because what is important in Kafka? One is the latency of the messages, and other is the throughput. So you should have low latency and you should have high throughput, and that is what Kafka maintains. Okay, but still it can be configurable. Okay, because it has to be, isn't it? It depends on how your application is. So what they are saying is tuning Apache Kafka for optimal performance involves tuning either the producer or the broker or the consumer. And how it is done? So the producer, we know that produces messages in batch sizes. So this is also a configurable parameter. So what is a batch size? So what is said is the batch size is the number of messages what you accumulate at a time in a batch, and then we actually send it to the broker or the topic or the partition. And so if we have a huge batch size, so what will happen is it is good for the throughput, right? If you have a very huge batch size, we wait for all the messages to be collected and then we send based on the batch size, then the throughput is very high. But then it is going to have an impact on the latency, because if you wait for long for all the messages to be accumulated as per the batch size, then we are waiting for some more time, and the first message which has waited for the last message to come, okay, it's going to have some latency impact, right? So so that is what one way of doing it. One is the batch size, and second is the linger time. So linger time will be like periodically you send messages. So you wait for a certain period, and whatever message you collect, you just send it, irrespective of whether they are as per the batch size or not. Don't bother about it, but just wait for a particular time. But in that case, what happens that you will end up sending lesser messages. So it might have even if the latency will be good in this case, but it will have an impact on the throughput, because then in some cases you will be sending only few messages. So that is what will happen. So or else it will have a inconsistent throughput. Sometimes it will have a very good throughput and sometimes it won't have. So you will have, these are the two ways you can tune based on what your application demands and what is the best for your application. So that is the way you can actually tune the producers. And second, what they talk about tuning the brokers. What is said, in a broker, all the information, all the messages are stored in partitions, correct? So you have many partitions, and then based on the partition sizes can be based on how we are actually configuring the partitions. Based on the partitioner, it can be small or it may be huge. And then it might also be, if a partition fails, a leader fails, then you have all those other stuff. So there might be what you say, loading issues. It might not be loaded properly. So all the partitions which are stored in different brokers, they won't be uniform. It's always going to be there, isn't it? Unless you are going to use something like a round robin. But if you're using a key based partition, which is more popular, I think, so you will always have some issues with the brokers being not partitioned properly, and therefore there will be an imbalance. And that is what they are saying is you can actually do a reallocation of partitions. And that is what the broker tuning is. I'm not sure how it can be done automatically. Maybe it's possible, but it looks to me more of like a manual way of tuning the brokers. But you have to do, because if there is more load on a single broker, then you will have bottleneck issues, and it might be impacting your latency in that case, right? So therefore, you can also have that is one way of doing tuning for broker, and same for consumers. You'll have more number of consumers, and they are reading only one partition, then it won't be good, isn't it? So you will have to have a single consumer, or maybe n number of consumer reading one partition, or the vice versa. So you'll have to actually even add either the consumers, or anyway you are, if you are adding partitions. Okay, so that is the way you can reduce and do some performance tuning in Kafka consumers, and that is the way the load across the whole system will be much mitigated. That is what it looks like. And so I thought that was also an interesting thing to discuss. So yeah, so this is what it is. If anyone has any more inputs on any of the topics what we discussed till now, yeah, please. Or any questions?
Yes. Yeah, so
Every-
partition you were yeah, so the partition part you were telling, right? I mean, if one of the partition having more number of these messages, right? So you can't have multiple consumer consuming from the same partition. I mean, if anyway one partition having lots of message, then yeah, delay will, the system will get some delay. You can't basically have multiple consumer consuming from the same partitions, right?
Mm-hmm.
So the delay will be there. So while pushing the message to the to the particular partition, you take the SHA of the key, so that you can make sure these keys are getting randomized. I mean, out of n this partition we have, right? So while pushing any key, you just take the SHA of the value. I mean, take the SHA and then modulus and push it to the particular partition. That way you can make sure it is kind of randomized, so that all the partitions having sort of same length of messages. Same length
okay.
of all the message which we are pushing.
That
So
still
the
depends
broker
on, like, that still depends on the key. Like how good is the key?
yeah, but it again depends on the application, what we are and the requirements. Yeah, but that is one way surely to do it. Exactly, I agree.
So every broker need to have equal partition, need not be, right? It depends.
Broker,
I mean, there are multiple brokers, right? So every broker need not have equal, like first broker has 3 partitions. That doesn't mean that second broker should also have 3 partitions.
no, that it's not that, because see, a topic will have replicas also. I will have partitions, and partitions will have replicas. So eventually, whenever we are getting a lot of messages, the state will be very different. So there will be many partitions on a single broker, and some brokers will be very sparse. It depends on how, yeah. So that is the way actually we are saying you can actually do again a rebalancing.
I mean, actually, I said partition, it should be topic. Like every broker need not have equal number of topics, right? It can vary. Like broker 1 has 2 topics, broker 3 might have any other number, or like 4 topics. It depends on the application use case.
Right. Yeah, topics is actually a generic term because it can go across brokers, and it can be on all brokers or only on few brokers. But yeah, partitions will map, because that is what is the granularity, right? In the broker's case, it's more of a partitions. Yeah, topic is more of a virtual entity. So the broker is a more granularity. Yeah, but yeah, that is one way to look at that.
So if you try to rebalance again the partition, the ordering will not be guaranteed, like partition ordering.
Yeah, frankly, I don't know. That is what they said. Maybe as you don't use it the way we are talking about this method, right? The key-based ordering. So then in that case, if it's a round robin and all the partitions are the same, we don't bother about what the messages are and the ordering in the message, then the rebalancing and partitions might make sense. But in some cases, if you have a partition and it can be converted into a topic because we want to again partition that topic. So there might be a way to just remove that partition and again form a new topic with subtopics like a subpartitions, because there is so much of load on a single partition. Why not divide that in different partitions?
Yeah, I agree on that part.
Yeah.
I think that would be more cleaner.
Right. Yeah, but
Yeah.
again depends on how it is implemented. But I'm just thinking loud. Yeah. Yeah, but it's a very complex system, right? The more I'm understanding, there are so much things, and it's really interesting also. But it has so much of good stuff, and the way they are talking about the challenges. Frankly, the challenges are very trivial here. They are not so much. They are actually very the impact what they have is very less, very rare cases, but they still want to address all those small issues, and really like that, they go to the lowest bottleneck and they try to handle that. So in turn, it will never happen. So most of these issues, whatever they are discussing, it might not have been happening in the regular day-to-day operations for most of the time. It might be having rarely in sometime in once in a year also, something like that. But still they want to address all these issues, and they really liked about that. And they're still keep evolving about the Kafka, and it has very good support, I would say.
In diagrams, they didn't show the coordinator node. One of the broker is also coordinator node, right? So which they didn't show.
Yeah, so I think the coordinator node will come to when we discuss about now the controller broker and the delivery semantics. So that has a lot of more information. Again, it's more technical intense. So therefore, I thought maybe keep it for the next session. Yeah, sure, we'll do that tomorrow. Tomorrow is Wednesday, right? Yeah, maybe Thursday or Friday we'll do. Okay.
Sure.
Yeah, and I think if no questions, then I'll just stop sharing. And if anyone wants to add anything, please.
Hi, Santosh. Actually, I came very late.
Okay.
Just wondering if we can get this recording on the group, on the chat.
Sure. Actually, Shashank, you maintain that. Yeah, sure.
Tomorrow in the Discord we'll share it. Tomorrow.
She will share in the Discord. Yeah. It takes a day to come.
Okay.
Yeah, no problem. Welcome, Shobham. Yeah.